Does anyone need them? Do you also have your copies of what you got in the library last week? Everyone good with that? Okay. All right. So what I'm going to start with is the pink guy. So if you want to get that guy out, we're not going to go through it word for word, but I'll touch on the highlights. You should read it over though, because all of the information I'm covering is in here, and all of basically the guidelines for the project are in that pink guide. And you don't need SciFinder because we're not going to talk about SciFinder today. As long as you have your SciFinder one somewhere, you're good. Okay, so what I'm going to cover is this is broken down into numbered sections. We'll kind of talk about the highlights about the numbered sections and talk about the project as well as what you guys are going to be preparing in the context of the proposal. And then just make sure that email list keeps going around and everybody ends up signing up on it, okay? So first thing here is a couple deadlines. If you are in a Tuesday, so that's under number 2, if you are in a Tuesday lab section, your proposal is due next Tuesday, so March 11th, and your lab prof will talk to you about how that's going to happen and how you're going to get it to them. If you're in a Thursday lab section, then it's due next Thursday, so March 13th. So make sure you've got those dates written down, and well, they are written down on the pink sheet, so make sure you keep awareness of those dates. Basically, we have to have everything we're going to talk about today as far as the proposal. That all has to be submitted before you leave for spring break, okay? And each lab section has specific guidelines for how that is going to be submitted, but it basically needs to happen next week, okay? So, couple of kind of basic guidelines that we use for topics that would be a good idea for the project, okay? We want a 3-step organic synthesis. We want you to be able to isolate each of those steps. So we want 3 isolatable steps where you're characterizing your intermediates in between each step. You want, ideally, one of those steps should be a carbon-carbon bond forming step, because those are usually a little bit more difficult synthetically. Then, you make something an acid, then you add base to convert it back from the acid, then you go on and, put on, you halogenate it or something like that. Sometimes that's not such a difficult set of sequences versus putting carbon-carbon bonds together and then purifying it and going on from there. So we want a carbon-carbon bond formation in there. A lot of you will be doing things that are based off of someone's research. So in that, usually, like Johnson, Gilmore, and Sanford know the guidelines for the project. So if they're assigning you something, it's most likely going to fit into those guidelines. But you should touch base with your lab prof too. So if you're doing a project for Gilmore, but your lab prof is Sanford, you should touch base with Dr. Sanford and let her know what project you're doing for Dr. Gilmore, and let her know what's involved so that she is able to okay or not okay, but that is what you're going to be doing, okay? A big part of what you're going to be working on this week is for each of those steps, you're going to need a literature precedent for those steps. And in a little bit here, I'll kind of show you what that can kind of look like. But that was in doing the whole couple-hour library training that we did last week. The whole reason for that is because you're going to need this primary literature for your proposal, okay? So you need a literature precedent for each of your steps. And it may be a literature precedent that is exactly what you're doing, or it may be a literature precedent that is similar to what you're doing, but similar enough to count as a precedent, okay? And in that, that's where the give and take kind of comes between you and your lab prof, deciding if something is an exact precedent, is it close enough to work, or is it really far off and that's not going to even be close and we need to find something else, okay? So you need those precedents before you can really put together any other part of the proposal. So that's where you're going to start, is with your literature precedents. And what I am going to send you, I'll show you here in a little bit what I'm going to send you, is throughout the pink packet, it talks about a chemical order form. You're going to need that. You're going to send it back to me, and you're going to send back to me a PowerPoint slide. So I'll show you what those are. But I will be sending you the blank chemical order form, the blank PowerPoint slide, and then the other piece that you need, which you're not going to send back to me, is you need the chemical inventory for what chemicals we have available. Because once you decide what you're doing, we then need to work on getting together, and that's what pretty much all the spring break is spent on, getting together the things you need, the chemicals and equipment you need to do your project, okay? So in a little bit here, when I show you an example proposal, I'll tell you about how you're going to fill that in based on the inventory, okay? So those are the 3 things you'll get from me based off of the sheet that you're signing. So like I said, everybody make sure you sign it. And like I said, you're going to, the 2 things I need, you're going to send back to me, because I'll take care of them. You probably will also be sending them to your lab prof as well, but I need them from everybody to put the whole big project together. Okay, so number 3, just like anything you've done in lab so far, you need to have a pre-lab written for each step before you start it in lab, okay? And so what that's going to mean for you starting your first step directly after spring break is when you come back from spring break to whenever you're starting in the lab, which may be during your organized lab section, or it may be even earlier than your organized lab section, depending on what your first step is, you need to have that pre-lab written in your notebook before you start, okay? The other thing that you need that's a little bit different than what you've had before is you need the procedure of what you're going to work on. And a lot of these literature precedents that you're going to get tell you how to do the step, but they kind of minimize the words and how they're going to do that. So what we want you to do is go through and write out what that step should look like. Have an outline of what that step should be, so you know it's basically your translation of that literature precedent. What is it actually telling you? So literature precedents are usually not as descriptive as your lab manual is going to be. They're going to use far less words to tell you how to do something. So you need to make sure you understand exactly what you need to be following, okay? So plan on having the pre-lab in your lab notebook, and probably even before you write that pre-lab, having a kind of annotated or more wordy procedure than what you're getting out of the literature precedent, so you know exactly what you're doing, okay? Then in your lab notebook, so we've kind of, with experiment 20, we kind of set you up for the project. In your lab notebook, you'll have your pre-lab, and then number 4 is talking about your experimental that you've written each time, every time you've done an experiment in organic lab. So again, you're going to write your experimental in your, as you proceed with your experiments in your lab manual, or sorry, in your lab notebook. And then that mini conclusion part that we added on to experiment 20, we did that for a reason, because each of your steps that you're doing for your project, you should write a mini conclusion in your lab notebook. And that should be written in your notebook before you do your next step, because that's basically your conclusions as to, did I make what I was supposed to make? Is it purified? Is it only half reacted? Did it not work at all? What happened in that step? So you need to write that mini conclusion in your notebook before you go on to the next step, and before you're planning the next step, because you need to know what you've got. You've got to take the product that you make, and you've got to do the characterization, NMR, IR, potentially GC mass spec, and figure out, Do you have what you're supposed to have or not? Okay? So mini conclusions for each of your steps. So really the three basic parts in your notebook are just like experiment 20, pre-lab, experimental, mini conclusion. Okay? Now, the last part is number 6. Then at the end, you're going to write a conclusion and summary for the entire project. Okay? And so again, experiment 20 is kind of, we've set you up to kind of do that because you're writing the conclusion over 2 steps, but this time you're going to write it for the whole project. So once you write and submit your proposal, your writing part in your notebook is basically going to be filling out your 3 pieces as you're doing the project, and then at the end, you're writing this big conclusion, okay? And it'll be, you know, word processed, all the usual guidelines, and we'll talk to you about what you need to put into that as we get closer to when that's actually due, okay? But make sure with the mini conclusions and then keeping the final conclusion in mind, make sure you do good characterization at each step, okay? Because you don't want to get to the end and find out you didn't do a really good job with it and maybe something wasn't quite what you thought it was, so you get to the end and then your final product isn't even what you thought it was. So you need to be really careful with that characterization and make sure that you know what you're making at each step. Or if we run into a roadblock and it didn't work well, then we need to replan and think about what our next step is. So you kind of, in your mind, need to think about when this all needs to happen, because your biggest chunk of time probably for you to work in the lab is going to be your designated lab time. That's the best time for you to be working in lab because that's when you're supposed to be in there, okay? There's going to be other times outside of the lab that you're going to be in there working as well, because not everyone's project fits nice into a 5-hour piece every week. But you want to think ahead. Okay, so, you know, I've got a Thursday lab, I completed the first step, I got data Thursday and Friday from that step. Over the weekend, you should be analyzing that data and as soon as possible figuring out, are you ready to go on to the next step or not, and be in contact with your lab prof about what's going on, okay? So you don't want to, okay, I've got Thursday lab, I'm going to wait till Wednesday night to analyze all that data and decide what I've got, and oh, you know what, it didn't work, so now what am I going to do on Thursday? Then you're going to miss a big chunk of time that you can be working on your project, okay? So in the grading for the project, you've got the proposal is worth 50 points, this conclusion, and you completing the project or handling your project or doing what you do with your project is 150 points, and then safety and technique is 50 points, okay? And so it's not a race to see how many people can get the 3rd step done and how fast they can do it. It's about the quality of the work as you're going, okay? So it's better to do 2 steps really well and have good full characterization than to do an iffy job on 3 steps and not be certain that at the end of 3 steps you have your product or not, okay? So you really, the independent part of the project you've got to take to heart because you're now the person driving this. And you're the person that's got to take the initiative to stay on top of what's going on in lab as well as staying on top of your characterization and staying on top of what's going on with your project, okay? Because we all have lots of people all doing different things that we need to keep on top of. So we can't be completely micromanaging what's going on. You guys have to take the initiative. Now here, kind of 2/3 of the way down on page 2, kind of a general guide, and this depends on really what you're starting with. And so talk to your lab prof and talk to, if you're doing a project for someone but it's different than your lab prof, make sure you know what this amount should be. But in general, you should plan on you're going to start with 10 grams of your first starting material, okay? But depending on what that is, you know, if it's 50 bucks for a gram, probably not going to be starting with 10 grams of it, okay? So you need to make sure that you know for sure, are you really starting with that 10 grams or not, okay? Because that's basically your starting point for kind of translating through the literature, okay? Because then you're going to need to scale things according to what you're starting with, okay? So general guide, 10 grams, but make sure you get that clarified for sure for your project what you're going to start with, okay? Or like, say you've got basically 2 starting materials. Maybe it might be better to do 5 grams and whatever molar equivalent of the other one you should be using. So it really depends on the project. So make sure you're clear on that, because once you get your literature, then you need to know your scale to be able to fill out the rest of the proposal, okay? And so here on page 3 is the grading that I just talked about. The proposal is 50 points. The lab work and conclusion and summary all rolled in together is 150 points. So what you do in lab, what you do outside of lab to stay on top of things and make things independent, and but yet, you know, we don't want things so independent that you're not getting consultation from your lab prof either. We're not just turning you loose for 5 weeks with no conversation. So independence, but back and forth conversation with your lab prof as well. And then your lab safety and technique is 50 points, okay? So the last week of classes, the Friday of the last week of classes, your report is is due. So April 25th is the last Friday of classes. That is when that final report's due. So you're going to turn in your notebook, you're going to turn in all your spectra and data that you collected, and then you're going to turn in your labeled samples, and your final conclusion is all due on that date, okay? So besides proposals being due next Tuesday for Tuesday labs, next Thursday for Thursday labs, here's your other due date for projects is the final due date of the final conclusion. Academic honesty, make sure we don't have to worry about that. Make sure all your data is your own. Make sure you're not falsifying data. Make sure that you are working independently on your project. Now, one thing that needs to be considered too is we want these projects to be unique amongst the group of you. So we don't want, you know, 2 people to decide to do the same thing. That won't work. But say you've got a synthesis that maybe, you know, you start on the first step the same way, but then you kind of diverge off of that in different directions, or you start differently but are going to come together to some commonality. Those things are okay, but no 2 people can do exactly or propose exactly the same project, okay? So last week we talked about handbooks and so forth in the library that are useful to use. And so between page 4 and page 5, I'm going to highlight which of those are going to be available in the labs themselves or are available in the periphery of the labs. So organic reactions, the library has probably the most complete set of the organic reactions set of books, but we do have, I forgot to look before I left what volume set we have. We do have some of them, okay? We don't have all of the most current ones, but we do have some of the organic reactions. So those are in 3123. Like if you're looking at the IRs, they're on the shelves behind you. Same with number 10, Fieser's reagent for organic syntheses. We've got volumes, actually it says volumes 1 through 17. We actually have volumes 1 through 23, okay? And the cumulative index for 1 through 22. Then we will have a copy of March's Advanced Organic Chemistry available. We will have a copy of Larocque's Comprehensive Organic Transformations, and we'll have a copy of a textbook of practical organic chemistry. We'll also have a book, it's Green's Protecting Group book, so if you need to put on a protecting group or take one off, it's a really good resource for that. We'll have the ACS Style Guide available, a copy of that, and we'll have Aldrich catalogs available as well, although online works just fine too. Now, these books that are in the labs, keep them in the labs. Most of these, so like March's, Larocque's, Vogel's, Fieser, we've got even Curdy's book of named reactions. Besides the Aldrich catalog, which those are just lab copies, all of these are one of our desk copies, textbooks, so we do not want them missing, okay? So keep them in the lab and don't take them away from the lab, okay? So they may go back and forth between the two labs, but at the end of the day, they need to all hang out together, okay? So make sure they stay in the lab, make sure they don't leave the lab, and beyond your designated lab section this week for preparing your proposal, they're going to stay in there until everybody's turned their proposals in. So even during open lab, if you need to use it, you can go in during open lab and use it, okay? Or besides the Feezer and Feezer chemical reagents series, all of the things I've just listed, the library has, and those were the books that we showed you last week. And remember with those, please don't check them out. If you use them, make sure you have them reshelved right away so that if someone else needs it, they can be used, okay? Because they are check-outable books, but we don't want them checked out, okay? Not during this time. The other part of page 5 is some useful chemistry journals that can be used for finding your literature precedents. So when you are looking up things for your literature precedents, these are 10 useful journals, and there's others beyond this. A lot of these you came in contact with last week when we had to do the little scavenger hunt looking for journals, okay? So remember everything we taught you last week about looking for journals that we have access to and finding out if they're online or if you need to get the hard copy of what's in the journal. And like I said, this list is not by no means comprehensive of all the possible journals that you could potentially get information out of, okay? But we do want to make sure that it is out of a primary resource, peer-reviewed chemistry journal that you're pulling your literature out of. And if you have questions about, is this a reasonable place for things to be coming from or not, let us know as we're helping you. We will definitely help you figure that out or not. So page 6 and page 7 then talks about the different pieces of the proposal. So I'm going to go through what those pieces are, and then I'm going to give you an example proposal of what that really looks like, okay? So first thing, you're going to give your name and date and lab section on the first page of your proposal. You want to give a stated goal of the project, so give a paragraph description of what is the goal of the project. What are you synthesizing, or what portion of a compound are you synthesizing, or why are you synthesizing this compound that will then be used to make X other compound? What is it that you're synthesizing, and why are you doing it, okay? And unlike other things we've done so far in lab, this can be a little bit, we can get a little bit more personal about what it is. So if you're synthesizing part of a molecule for Dr. Johnson, you'll explain that you're synthesizing whatever molecule in 3 steps that then will be used in Dr. Johnson's lab for whatever, to be combined with another compound, to be used for further synthesis. What will it be used for, okay? Then you want to give a reaction sequence showing starting materials, reagents, solvents, and conditions. And you want to give a little bit of a paragraph descriptor about that step too. And then number 4 is you're going to give a literature precedent for that step, or be very clear about if you're doing exactly the same step, then you're just going to show that step and make it clear that it is the literature precedent is exactly that step, or you'll show your step and then what is shown in the literature. So your proposed step versus what's shown in the literature. So I'll show you an example of that here in a second. You're going to give a table of physical constants, so same information that you've used before, melting point, boiling point, molecular weight, density, calculate your moles, calculate how much you're going to be using. But we also need toxicological properties and hazards for the starting materials, reagents, solvents, and products, okay? And Aldrich catalog is a really good resource for that. There are other resources online for that information as well, but Aldrich is a good one to start with if they carry the chemical that you are interested in. A separate list of needed amounts of starting materials, reagents, and solvents for your proposed synthesis. So that's the table I'm going to show you here in a minute. You're going to send this to me once you have it completed, okay? Then you also, so you've got two different tables. You've got your physical constants table, then you've got this chemical order form, basically. The chemical order form I don't need your table of physical constants, okay? List of any special equipment, attached photocopies of the literature precedents and procedures, and then you're also going to submit this PowerPoint slide, and I've got you don't have to create it on your own. I've got the template I want you to use, and if you want to go away from it, I'm still going to put your information in that template. So keep it in the template that I give you, because we make a big poster of everybody doing projects and what they're doing to be displayed outside of the organic labs. So not trying to stifle creativity there, but it looks better if things are kind of similar versus everyone's similar but one kind of thing. So stick to what I am sending you. Same with the chemical order form. I know everybody has their own style of how to fill out a spreadsheet and blah, 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 blah. Conformity with that one too. The reason is I take your spreadsheet and I put it in the master spreadsheet, which ends up like 6 pages long of everybody's spreadsheet put together. So I can't have, your formatting and someone else's formatting and this formatting that. It needs to all stay together. So with the spreadsheet, keep the formatting what I send you to, okay? So you're going to turn in 2 copies of all this, 2 copies of your proposal and 2 copies of your literature precedents. And with those literature precedents, if you have any supplementary information that was important to your proposal, make sure you include that as well, okay? And it's a good idea to make it very clear in those precedents for, like, where do we find your procedure? Highlight it, circle it, step 1, make notes so we know exactly where to find it. So, and kind of, it makes it easier on us, like if you have 3 different precedents, 1 for each step, kind of put them in step order. That makes things a little bit easier too. So the reason you give us 2, we will grade 1 and give it back to you after spring break. And we will keep 1 because we always need to know what you're planning on doing, okay? So 1 is for us to keep, 1 is for you, but we need 2 copies of everything in doing that when you originally turn everything in, okay? And then we talked about everything needs a literature precedent. So here's kind of an example. Say we wanted to do this reaction in this alkylation reaction in your proposal, and the following reaction is a good precedent. So what you would do is list this reaction in your proposal, and then you would then list this as precedent reaction, and then you would give me all of the pertinent literature information using the ACS style guide. Okay, so this is where the ACS style guide comes into play. You want to make sure all your references are cited correctly. Okay. The other thing we're going to teach you how to do this week is you need to know how to use ChemDraw. Okay, so ChemDraw is available on all the Campus Clone computers, and we're going to give you a tutorial this week on how to use it, and then you're going to use it in your proposal as well as your final conclusion that you write at the end of the semester, okay, or end of the project. Everything I just went over is right here. We now give you also a checklist, so you can just check off, make sure you've got all the pieces before you come to hand it in, okay? And again, a reminder that chemical order form is going to be emailed to me, and your completed PowerPoint form is going to be emailed to me. So your proposal is not considered complete until you have handed in everything that you're supposed to hand into your lab prop and emailed me these 2 things, okay? So if you hand everything in but don't email it to me, it's considered that you didn't complete your proposal and you won't be able to do the project, okay? So if it's not complete before you leave, you won't be able to do the project. And for these 2 things, for every lab so Tuesday morning, Tuesday afternoon, and Thursday morning, these 2 things need to be to me by noon on Thursday, March 13th. Okay, so if you're in a Tuesday morning lab, Tuesday afternoon lab, or Thursday morning lab, noon by Thursday, March 13th or sooner, okay? I will take everything as early as possible because I basically have to put that chemical order form all together Thursday afternoon, and immediately Friday morning we're starting to pull chemicals, okay? And the Thursday afternoon labs, because Thursday afternoon is your lab section, by 3 o'clock Thursday, March 13th, I need these two guys, okay? And kind of remember, you know, the earlier you want to hand in things, as long as everything is okay with your lab prof as far as what you're handing in. So you want to run things by them maybe once or twice to make sure everything is complete. The earlier you hand things in, the earlier you're done with this, and most likely the earlier you then can go on spring break, okay? So don't wait till the last minute, but those are kind of the final deadlines, because I've got to put all this information together in, you know, less than 24 hours to be ready to pull chemicals. So here is an example of a proposal, okay? So we've got this opening paragraph describing what the three-step synthesis is going to involve. And then we've got step 1 with a description of what is involved with step 1. And then this is the first step that was proposed, and it actually, the proposed step and what was in the literature pretty much matched, except for they were going to use a different solvent. And then the complete literature citing is given, okay? So, and you know, name, date, lab section up here. So this is like your first on your checklist. That's basically, you know, 1 through 4 is basically given here, okay, for step 1. And then step 2, give another paragraph, description of the, in general, description of the step, and then give what that step is, which again, they were following the same literature precedent, although they had multiple literature precedents. So that is possible too, that two precedents will cite and give information for the same reaction. And then step 3, paragraph, and again the step, and then the literature precedent. And so if you're not following exactly the literature precedent, then use like the example on the last page of the pink packet that shows give the proposed step and then give the literature precedent step. Okay? And in that paragraph, you want to, you know, in general, describe what's involved in that step, but, you know, if it's a specific type of reaction, you'll probably want to mention the reaction, the mechanism it's following. You know, if you've got it's got to be cooled at -78 degrees, that's probably a good idea to mention it at that point. If it's got to be heated to, you know, 200 degrees, it's probably good. Or there's an 18-hour reflux involved. That general information is a good idea to put in that paragraph. What we don't need is, you know, 0.25 mils of this reagent will be added to, you know, 5 mils of this reagent, that kind of stuff. But in general, you could talk about, well, this reagent will be stirred at -78, and then N-butyl lithium will be added, and then it'll be allowed to warm up overnight, and then worked up the next day or something like that, okay? So here's an example of the physical data table and hazards and toxicological properties. So you want to give the compound, a good idea to give the CAS number. Here's kind of what you're used to doing: molecular weight, boiling point, melting point, density, amount used, moles used. And then a column for the hazards and toxicological properties, okay? And sometimes, like this, you can kind of format as you wish. Like you could maybe put like this in one table and then do a second table that's all the chemicals and the hazards data if you want to do that. Or if you can fit it all into one table, that's fine too. So kind of decide if you want to break it up into 2 tables, 2 smaller tables, or 1. But this is all the data that you need to have, okay? So basically the same data you always had, add CAS number, add hazards and toxicological properties, all right? And then this is what that chemical order form is going to look like. So this is what I'm going to send to you tonight, is the blank copy of this. You want to list chemicals with the numbers in the back. So this is what is shown here. So instead of 2,2-dimethoxypropane, what you want to list is dimethoxypropane, comma, 2 dash, okay? Because that's how, for the most part, things are listed in our inventory too, and how things are alphabetized, and for us alphabetizing and putting these tables together, it works a lot better to follow that convention versus putting all the numbers in. Otherwise, I have to go through and fix it, okay? So if you can help me out and do this, make things a lot easier. Also use words, don't use formulas in here, okay? So don't, give me MEOH for methanol. I want, methanol spelled out. The other thing is, this is where this purple sheet comes into play. Okay, so these are the things that we are going to have available for you in the organic lab. A lot of what's on here is stuff that's already been available for you. Okay, so we've got a list of basically the red can solvents. That's what that top part is. Okay. Then we have dry solvents. We have a solvent station that has these 7 solvents available. Okay. Then we have acids and bases that are going to be available. And then the drying agents, we've always had magnesium sulfate. We'll also have, sometimes you don't want to use magnesium sulfate, you want to use sodium sulfate. We'll have sodium sulfate available, okay? So double check with this. You don't need to put this on here if you're not using, buckets of this. But, if you're using, 10 mils, 25 mils, that kind of stuff we should have available. If you're going to need, 4 liters of something because you're going to run a column, then maybe go ahead and put it on your chemical order form so I can keep track of that you're going to need that quantity, okay? But otherwise, if it's on here, I don't need it on here if it's a small, reasonable lab scale size amount, okay? So you're going to have your chemicals. You're going to have your CAS number. You need a CAS number for everything. And these are the chemicals you need. It's not all your products on here too. It's just the chemicals you need to do your project beyond these guys, okay? You need to give the amount you need, okay? Then you need to give the amount on hand and where it's on hand, and I'll show you in a minute here how to find that, okay? Then for the things that don't have enough on hand, you need to give the amount that needs to be ordered, okay, or found in the department. Then you need to give who would be a supplier for that, and the catalog number. Okay, these 2 columns you need to fill out for every chemical, not just the ones that you think need to be ordered. Because just because it says it's in the inventory, there's not a 100% guarantee that we can use it or that it's available. So we're going to look for it in the inventory and hopefully we can use it. But if we can't use it, we've got to order it, and we need that ordering information. Otherwise, we can't order it for you. Okay. Then you're going to give your name on every line, your prof's name on every line, and what step it's going to be used for. And the reason for this part is, say you need something like super expensive, and it's in the 3rd step. Well, you know what? We're probably going to wait until it looks like that 2nd step is going to work out or not before we're going to order that really expensive 3rd step thing that you may or may not get to, okay? Kind of general rule is $1 a gram is kind of your guideline for what is reasonable to be ordered, but things get a little bit different when we're talking about people's research projects too as to whether it be useful or not. So you need to be in contact with your lab prof about the cost of things if things are more than $1 a gram, and you need to be in contact with the person you're doing the research project for if it's more than $1 a gram, okay? So this is the table you're going to email to me, okay? As far as location, things that we, actually I'm going to put 2 things up here on the board for you. Rooms that are kind of our hierarchy of where we can look for things. So anything that's in the organic lab area, so these are the 2 organic labs, and this is the organic stock room. Any of those are free reign, okay? It's possible things will be in 3123 because that's where our freezer and refrigerator are, and that gets a little bit fuzzier as to whether or not we can use it, but you can still list that down, okay? Then you kind of want to think about the organic lab profs as far as their labs, okay? So Johnson is 3116, Gilmore is 3120, and Sanford is 3126, and this is all my lab information because I just have an office, okay? So these are, especially if you're doing research for them or a project for them, then if it's listed in their lab, it probably is okay that we use something out of them, okay? Then after that, you kind of want to think about third floor chemistry. You don't really want to creep into biology. And second floor chemistry. So when you're looking at room numbers, make sure it's a chemistry room number, not a biology or geology or nursing or you know, some other occupant's room number besides chemistry in the science center. Okay, so this is kind of the hierarchy you want to use. This, 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 and this. Okay. Now, besides Aldrich, so Aldrich we want as our primary. We want you to be looking at Aldrich or Sigma Aldrich for your chemicals. But other chemical suppliers you could possibly use: Acros, Alpha Acer, Lancaster, GFS, Luca, TCI, and TCI kind of has multiple categories. Like they have different catalysts, different organometallics, different types of catalogs. Okay, so it's not just a TCI catalog. Fultz and Bauer, MP, the company name is MP Chemicals, and Matrix Scientific. Okay? So these are also potential sources, but if you're not finding it in Aldrich, make sure you're talking to your lab prof and the person that you're doing the project for about what's going on. Yes?
What about Fisher?
Fisher is a possibility, although usually what we can get from Fisher, we can get from Aldrich. And like the bulk solvents and stuff, we'll worry about that kind of thing. So, but like I said, Aldrich is our first choice. Okay. So let me show you now. So I basically showed you the chemical order form. I'm going to show you what the PowerPoint slide looks like, and then I want to make sure. Has everybody signed the sign-up sheet too for email? Or is there anyone in here who hasn't? Let's count how many people. I should have like 26 in here. So.
There's 21 names on the sheet.
Okay, so not so good because we're missing some. Okay, so this is what the blank order form is going to look at. Like I just showed you what it looks like completed. Okay, so I'll send you that. This is what your PowerPoint slide is going to look like. Okay, so I'm sending you the template with me on it. You know, delete me, delete the information pertaining to me. But I do want you give your name, give Chem 256, give your lab section, give compound, your final compound you're drawing. It may be a couple final compounds. Do give a picture. Like sometimes people are hesitant to do that, but usually if you don't, it's like one or two people that don't. But remember that I am putting, this is going to be on a poster posted in the chemistry department. So, use discretion with the picture that you choose. But it doesn't need to be your ID picture either, okay? So make it something that it has to be publicly displayable, or I won't use it. But do include a picture. And then you want to give a brief description of your project, okay? So that chemical order form, PowerPoint slide, those are the things you're submitting to your lab prof, but you have to send me those digital copies, okay? So then the other guy is, here is our inventory, okay? And like, if you want to go page by page through this, it'd be, really painful. So you don't want to do that, okay? So what you want to do, let's get to the top of it here. So look at, the tag number isn't really a number you need to worry about. That's just the coded number in the department for the inventory, okay? Location, although our location kind of lost an N here. These are the room numbers. So this is where you want to consider, room numbers. Now another thing that I didn't put on there, which kind of goes in here, 1033. That's our general stockroom. So if it says 1033 on it, put that, before general third floor chemistry or second floor chemistry. Okay. Then don't worry about so much the vendor. It gives a catalog number, but do your searching to find the catalog numbers as well, and if they agree, well, that's really good. And then it tells you the amount that's on hand, so here's a number and what unit it is, grams, milligrams, what we've got. Don't worry so much about the receiving date. So what you want are location, is it somewhere we can possibly get that chemical from, and how much do we have on hand? Do we have enough for you to be able to do what you need to with your project, okay? Now what I recommend doing is use Control F and typing in what you're looking for. So say we're looking for chlorobenzoic acid. Then you can kind of tab through and look for the options for chlorobenzoic acid. So it's got 2 chlorobenzoic acid. Maybe you wanted 3 chloros, so you can say find next. Oh, it found 3,4 dichloro. Oh, look, it found 3 chlorobenzoic acid, okay? So I would probably not put the numbers on quite yet because some of the numbers are listed before, some of them are listed after, so I don't want you to not find it in the inventory, even though it probably is there, okay? Or potentially is there. So try it without numbers, but type the rest of the information in, and then try and find it in the inventory, and then once you find it in the inventory, like this case, the 3 chlorobenzoic acid, well, 3109 and 3121, those are all, either organic lab or organic stockroom, so those are all fair game. Or like looking on the next option, 3123, we've got per benzoic acid, so not the same thing, but looking at room options, 3123 potentially, 3114, because that's if you're doing a Johnson project, potentially, or the lower stockroom. So just the numbers you want to watch for the room number are right there. So just make sure you pay attention to that and not just list the first thing that you find, okay? And like I said, I will send you those 3 things tonight so that the people start working in lab tomorrow have those available, okay? Questions you guys have over any of this? Yes.
So we do go to lab this week?
Yes, you do go to lab. Oh, actually, I have one more thing to talk about. So yeah, do plan on going to lab. Like I'm starting my lab 7:30 tomorrow morning. We're starting lab. So you will be in lab this week working on your proposal. Like the best case scenario with lab this week is you get so far, you pretty much have your proposal done by the time you leave or have all the information for it. That would be ideal. Another thing, couple things, bring your laptops with you because you can, once you've signed up for SciFinder, you can use SciFinder in the lab so you're not having to use what few computers we have in the organic lab area. And then another thing is when you are once you have your literature precedents, you need to think about the scale of the literature precedents, okay? So they're not probably going to be written exactly the way you're going to do your reaction. So what you need to think about is with reagents, you need to keep mole ratios of what you're using and what they said to use the same, and keep concentrations in solvents the same, okay? So you're gonna have to do some calculating through to make sure mole ratios stay the same and concentrations with solvents stay the same, all right? And then when you get to looking at workups, those are usually, you know, say you're doing it 5 times the scale of the precedent, usually then, you know, it says 10 mils of dichloromethane to use for the extraction, you probably would use 50 mils. Usually it's by scale for the workup. But for the reagents and the solvents, reagents keep mole to mole ratios, solvents keep your concentrations, what they're supposed to be based on that precedent, okay? And then workup, usually you can, it doesn't have to be exact for the workup, all right? Other questions? Yes?
So we don't have to do anything in our lab notebook until after the proposal's like...
Right, yeah,
Okay.
probably not really doing anything during the proposal writing until it gets to the point it's time to write your pre-lab.
Okay.
Your very first pre-lab. Oh, and actually, shoot, one more thing, sorry. Hang on, one more thing. I forgot the green sheet, guys. Okay, so green sheet gives you information on one side. It gives you information about anhydrous conditions or inert conditions and how we will take care of those in lab. So if something needs to be kept anhydrous, we'll need dry glassware, we'll need a dry atmosphere, we'll be able to use nitrogen in lab to do that. The other thing is inert conditions, so sometimes, you know, a little bit different than dry. We just don't want oxygen in there. Then things that, there's a list of chemicals that you need to keep in mind for inert conditions. So make sure you read over these things, and make sure you're aware of these things when you're looking at the literature precedents, because they may tell you, you know, in dry this and dry that, so that means anhydrous conditions. Or in an inert atmosphere, so that's saying inert conditions, okay? The other side of this is chemicals, so there is limit to what we can do, okay? And there's specifications in the pink sheet as well as on this green sheet. So this is kind of a list of things that we would need to dispense for you. They're harmful enough, we don't want you to be handling these chemicals. Or these are the conditions of, we don't want you to use these at all kind of thing, okay? So if you're running into seeing things under this list or this list, talk to your lab prof. Or if you're running into something that's very similar to things listed on here, talk to your lab prof as you're going along, because you don't want to end up proposing something that uses all chemicals we can't use in the lab, because that would be, you know, kind of a bummer. We'd have to start over. So really pay attention to this green sheet as you're looking at different chemicals that you're potentially going to need and the conditions you're going to need. Okay, and I think now, sorry.